Okay, as you're aware, a straight line or a curve can be described by an equation, and likewise, so a circle can be as well. Okay, so any circle can be described in this general sort of way here using that general equation there. Okay, so x minus a all squared plus y minus b all squared equals r squared. And it turns out then that the a and the b here, the coordinates for the center of the circle, and the r squared there, okay, is squaring the r, which is the radius of the circle. Okay, so in A here, it's got here a circle with center 2, 3 and radius 5. So we're asked now to write an equation for it. So if you think about it, this corresponds to your A and B, okay, and of course this is your radius, yeah. So using the general formula there, you'll have x minus a, so it'll be x minus 2 all squared, plus y minus 3, okay, because that's what b is, all squared, equals then to r squared. Okay, so r is 5, so we'll square that. So you end up having x minus 2 all squared plus y minus 3 all squared equals to 25. Okay, so that equation there describes this circle with center 2, 3 and radius 5. Okay, let's look at the second one here. Okay, so circle with center minus 1, 4 and radius root 5. So substitute in your a and b. So remember now that is your a, that is your b, and there is your r there. Okay, so we've got x minus a. Okay, now a happens to be a negative here. Okay, so we need to put in negative 1. Okay, all squared, plus then y minus b, so y minus 4 all squared equals then to r squared. So r is root 5 and we've got to square it. Okay, now when it comes to simplifying then, obviously in that bracket you've got double negative, which becomes a positive. Okay, and that one stays as it is, and then of course you're squaring a square root, so cancel each other out, so you just end up with 5 there. Okay, now you could be asked to describe the equation of a circle given this information here. Okay, so circle with center 2, 2 and passes through the point 10, 8. So I've mocked up on the computer here this situation where you've got your center and there is a point that the circle goes through. Okay, and we need to write it in our form. Now think about the equation for circle, general equation. Here it is here, of course. Now you need your center coordinates AB, but you also need a radius. Okay, now we've got the center here, 2, 2. Okay, but we don't know the radius, don't we? We don't know what that value is there. Okay, that essentially connects these 2 points. All right, but we know if we've got 2 points, we can work out the distance between them. Okay, using our understanding of Cartesian coordinate geometry. Okay, so if you remember to work out the distance between 2 points, in this case it would be r, you do the square root. Okay, and the general formula is x2 minus x1 all squared plus y2 minus y1 all squared. It's Pythagoras' theorem. Okay, but that goes back to the topic on coordinate geometry and the formula, of course, here that we sort of need to remember. Now, all you do then is substitute in the values. So you can call this your x2, y2 if you want, and so that would be a second coordinate, and you can call this your first coordinate if you want, x1, y1. So in the square root then, you've got x2, which is 10, take away x1, which is 2, all squared, plus then y2, which is 8, take away y1, which is 2, all squared. Okay, now you can work that out in your calculator, right? But it just so happens that just comes out to be perfectly 10. Okay, and then now you've got the center and then you've got the radius, you can then put it into the general formula. So let me just remind you the general formula. Okay, where the center is AB, so 2 for A, 2 for B, The radius is 10. And don't forget that you've got to square it, so I'll do that straight away, and you get 100. So there's the equation for the circle described here, with centre 2, 2 and passing through the point 10, 8.